Our next topic is an overview of the food and beverage industry. The food and beverage industry has several pain points, some universal to most businesses and some unique to the industry, including seasonal demand is often a big concern in the food and beverage industry. Your company needs to be able to meet the demands that vary throughout the year. The trick is to have enough capacity to meet the peaks without overkill. High product turnover is another concern. You must be able to switch over to varying products while maintaining throughput. High flexibility of new products and multi-variety packs are also common, so your facility must be able to produce and package everything for timely deliveries. Maintaining quality and freshness is another major concern. And equipment is typically expensive, so optimizing the use of equipment can have a big effect on your profitability. Finally, energy costs are rising, and from an environmental perspective, green is in. The solution to these problems has two ingredients. First, dynamic simulation modeling of systems using a tool such as Siemens Technomatics plant simulation software provides a powerful virtual environment to test and improve a system's design and operations to address the issues listed earlier, such as management of seasonal demand, inventory optimization, development of flexible systems, etc. Among the numerous simulation products that I've used, plant simulation also happens to be my personal favorite tool due to its unique, powerful features. Second, while plant simulation provides a powerful engine to build, analyze, and optimize your processes, the Food and Beverage Library turbocharges that engine by providing objects and tools that slash the time required to build, analyze, and optimize your food and beverage simulation models, and provides a high level of detail and visual realism. Our next topic covers the details of our plant simulation food and beverage solution. A big benefit of this solution is that simulation lets you visualize the process. Sometimes just watching the simulation run can help you to identify bottlenecks, not to mention being able to communicate your process to others. One of plant simulation's many strengths is identifying bottlenecks and breaking those bottlenecks with what-if games. Simulating your process can help you to invest in the right equipment. You can make sure that it provides the throughput required and lets you see the impact of alternative investments. The what-if capabilities of Plant Sim let you experiment with and optimize product mix and scheduling. Similarly, the what-if capabilities of Plant Sim in the Food and Beverage Library let you optimize cleaning strategies. We can also optimize batch sizes and stabilize production by smoothing the flow. And you can minimize inventory and work in process to optimize your process and ensure freshness. Simulation also lets you minimize waste. Finally, simulation helps to ensure that capacity is sufficient for future demand. To visualize and simulate your food and beverage process, the Food and Beverage Library provides several industry-specific modeling objects. These objects also slash the time necessary to build a simulation model. Two source objects include fluids and solids into the simulation according to a user-defined schedule. The tank object holds fluids. The stirrer tank is based on the tank but also includes a processing time to simulate stirring. The mixer is a special tank that can process both liquids and solids and mixes them together. The filling object is another specialized tank that consumes liquids and produces solids that represent filled cases like bottles or filled molds. The diverter singularizes products that have been filled into forms by the filling object. The palletizing object loads products onto pallets. The storage object stores pallets. It optionally lets you directly enter truck orders according to delivery dates. Finally, there are several moving units which move through your process, including mass MU, produced by filling, piece, produced by the diverter, carton, to put products in, pallets contain cartons, forklifts move pallets, and trucks make deliveries. As you may know, discrete event simulation tools like PlantSim include features that let you analyze your facility, like locating bottlenecks and optimize it by quickly and safely playing what-if games that let you test proposed improvements on your computer. The Food and Beverage Library adds to this already powerful arsenal of built-in powerful tools. Visualization of your process helps to understand and analyze your process by showing flows through pipes, tanks filling and emptying, etc. Bottlenecks like a tank being empty for too long can often be pinpointed by just looking at your simulation run. On-screen statistics can include overall data like total pallets produced and number of orders delayed, as well as detailed statistics for individual objects like the contents and status of a tank and its maximum capacity and current capacity. Time and state graphs are a great way to pinpoint problem areas. For example, a station waiting for material too long. Data tables like truck orders for a storage object let you see the details for each delivery, like the exact date and time. The scenario control lets you play what-if games by specifying different data sets for mixers and truck orders. PlantSim's built-in tools can also help to analyze and optimize your process, including Experiment Manager that can automate the running of all the scenarios that were set up in the scenario control, as well as varying other parameters. The Bottleneck Analyzer can help you to pinpoint bottlenecks, and the Sankey diagram lets you visualize the flow of fluids and solids. Here's an example. The thicker the line, the greater the flow. In the example shown, you can see that more cacao than sugar or milk powder flows into the mixer here. And now, the moment you've been waiting for, it's time to show the full video of a simulation of a demo chocolate factory, so you can see how a food and beverage process is visualized, analyzed, and optimized. Let's assume that you have several chocolate factories. Due to rising seasonal demand, production must be increased at one factory that currently only produces milk chocolate. Now we must also produce and add coconut chocolates, nut chocolates, and chili chocolates to the normal delivery schedule. Some people think you need to add some equipment or change processing times, but you think that changing batch sizes might meet demands without investing in new equipment. Instead of diving in and making potentially poor investments or trying other potential solutions on the plant floor, you decide to use plant simulation with the Food and Beverage Library to rapidly model your factory and to safely and quickly play what-if games to determine the optimal solution first. Step 1 is to build a plant simulation model of your existing factory. PlantSim's unique class library contains all the default modeling objects and analysis tools in the top 6 convenient Windows-like folders. The Food and Beverage Library's objects and tools appear below that. The Material Flow subfolder contains the main food and beverage modeling objects. To build a model, you can drag objects from the class library like source fluid to supply sugar syrup raw material in a PlantSim frame, which is a window that contains a simulation model. Since this is the first object in our frame, the Food and Beverage Library saves you time by automatically adding standard components after you click OK, like the station statistics chart. Alternatively, you can also click on an object you want to add in the Food and Beverage toolbar, like a tank to store your sugar in. Then you just double-click to edit the default data for an object, like the maximum volume of a tank or the flow rate. To transport the sugar syrup to the tank, we put a pipe between them. Using the model building methods that you just saw, either PMC, you, or an engineer on your team builds a plant sim model of your existing milk chocolate only process. This is done to serve as a baseline for your what-if process improvement experiments and to verify and validate that the model is correct. Let's take a tour of the model while it runs so you can see tanks filling and emptying, mixers mixing, etc. 3 sources fill 3 tanks with our raw materials for chocolate: cacao, sugar, and milk powder. The first mixer mixes the 3 ingredients by weight according to a batching formula in its input table. Chocolate batch from the mixer goes through a rolling process that is modeled as a stirrer tank, then fills the tank below. Conching is the next process modeled as 3 stirrer tanks in parallel, since it has a long processing time that includes slow and fast stirring cycles. The second mixer is the final step for making our end product. You may remember that our existing factory makes only one product, milk chocolate, so for now only one ingredient enters the mixer. Since the existing mixer can accept up to 5 ingredients, it can be used to produce the 3 other products that we need to make for our seasonal demand. So we went ahead and added sources for nuts, coconut, and chili. Each one will be mixed with chocolate. All 4 products will have their own batching, ingredients, formulas by weight, and processing times. Additionally, since several products are being made, cleaning strategies and times are also inputs. All of these parameters can be changed for process improvement studies. The filling object produces solid chocolate in a mold that holds 12 pieces. The diverter singularizes the mold into 12 individual pieces of candy. Each piece of candy is then wrapped in foil. Then 10 pieces are put in a carton. Next, 10 cartons are put on a pallet. Then a forklift puts the pallet in storage. Finally, a forklift loads 25 pallets into a truck according to a delivery schedule specified in storage. You may have already noticed that being able to visualize your process like this can often help you to pinpoint problem areas like a tank being empty for too long, a mixer waiting for raw material, or a process being longer than the rest. The overall statistics displayed on screen show what we already know, that the current process is producing the number of pallets that we want for the 5 days simulated and that no orders were delayed. So all trucks were loaded at the right time, so everyone is temporarily happy, from your customers to your board of directors. After years of relative bliss, making one delicious single solid milk chocolate candy, you are now faced with a worst case rumor that each delivery truck will include the current 25 pallets of solid milk chocolates along with 5 pallets of nut chocolates, 3 coconut chocolates, and 2 chili chocolate pallets, delivered according to the same schedule. While several experienced team members argue about whose solution, like adding extra equipment, is best, you decide to use PlantSim to see if your gut feel theory of using existing equipment and changing the standard batching strategies will work. The powerful scenario control is used to quickly create 3 scenarios, 1 for the existing process and 2 for your what-ifs, which change the second mixer's product and batching strategies and the truck delivery orders. Then the experiment manager automatically runs the 3 scenarios and displays a shareable report. The overall statistics for your 2 what-ifs, scenario 2 and 3, don't look good. 20 out of 28 late deliveries for one and 19 for the other. But when you dig deeper into the detailed truck order statistics for scenario 2, it isn't quite as bad as you feared. Delay times varied from 32 minutes to almost 20 hours, and no delivery is more than 1 day late. Scenario 3 is better. Delay times varied from 32 minutes to 15.5 hours, and less deliveries were a day late. Instead of rejecting these scenarios, you call the appropriate customer and ask if the worst case 20 hours late is acceptable. He rejects that. But when you ask if scenario 3's 13.3 hours for that customer is okay. He agrees. Calls to other late delivery affected customers for scenario 3 also agree. So you're all set to show your board of directors how your existing equipment can meet the new seasonal demand with scenario 3. Shortly after the new seasonal demand rumors started, more rumors started about year-round demand increasing, 10, 20, maybe even 40%. The marketing people did some taste test studies that resulted in most people liking all 3 added products a lot. So it wouldn't be too surprising if a great thing happened to this plant, like these new rumors coming true. So besides your seasonal demand solution, you decide to perform a full throughput improvement roadmap analysis using pallets produced per day averages as the metric. Before doing anything like trying the many suggestions that have been made by others, you look for main bottlenecks first by taking a look at the station time and state chart for the base model. As you can see, the 3 conching stations are doing a lot of stirring work while the mixer that it feeds is free for a lot of time, a classic symptom of a bottleneck. So you start by seeing what adding another conching station will do, then try out other potential improvements. To improve communication, you take advantage of PlantSim's powerful hierarchical modeling capabilities and the unique ability to run more than one simulation model at once by providing a single screen overview of the 4 scenarios in your throughput improvement roadmap. While running this, you can double-click on any scenario model to see it running, like watching the 4th conching tank in action that was added in scenario 2. Let's jump to the results of running our throughput improvement models for 5 simulated days. Adding the 4th conching tank kept the 2nd mixer busier and increased pallets per day from 335 to 344. Decreasing the processing times of filling, rolling, packing, and palletizing results in a dramatic increase to 454 pallets per day. Finally, improving how the conching tanks are filled brings us up to 560 pallets per day, way behind even the highest rumors. So now, for your meeting with the board of directors, you are fully armed with proof that the plant can meet seasonal demand by changing the batching strategy of the mixer without investing in any more equipment. Plus, you can show them a set of steps that can be taken if year-long demand increases. More detailed analysis would have a good chance of coming up with even more efficient strategies. And now back to our PowerPoint slides. Well, I hope you could see the power of using that Food and Beverage Library where you can actually watch the tanks filling up and things flowing through the pipes and everything. And now, before we take questions, we'll wrap things up by looking at the highlights of a few case studies that show how useful our solution can be, and briefly tell you about a couple other nice PlantSim options that you might find useful. In one case, a bottle manufacturer wanted to explore multiple investment options where the magnitude of impact was hard to predict because the return on investment of each configuration hinged on the system's capability to absorb production fluctuations and uncertainties. Automated experiments speeded up the process of comparing the various scenarios. The result was a system that was more balanced throughout time, and throughput increased by 23%. Another study wanted to determine the number of lanes and lane speeds to support modification to an end-of-line palletizer system. This resulted in a system that not only cost less, but also increased throughput by 700 bottles per hour. Another simulation focused on improving the production of ready-to-eat cereal at the packaging area. One scenario that was successful showed that the throughput could be maintained by removing a bagging machine, by modifying the system configuration, or by increasing the speed of the conveyors. In another case, simulations showed that the desired throughput could be met using one less tank, and cost was reduced by $543,000. After playing what-if games with various system configurations, another simulation resulted in reducing energy consumption by 5%. You may recall that PlantSim can also connect to PLCs to optimize control logic before implementing it on the plant floor. One food and beverage simulation included such virtual commissioning, resulting in a 70% commissioning savings. You've seen the benefits and return on investment statistics of several individual food and beverage simulation. This slide shows the average return on investment experienced by 600 plant simulation users in a wide variety of industries. Results include a 12-to-1 average value cost ratio. I've witnessed this kind of return on investment in projects that I've been involved in. As you can see, Plant Simulation's open architecture allows us to interface with nearly any other software product, including databases, spreadsheets, factory CAD, even PLCs on the factory floor. If you currently use or plan to use Team Center, then you'll be able to share any PLM data that resides there while maintaining the advantage of keeping current data in one place. Besides the Food and Beverage Library, other add-on libraries are also available for PlantSim. The Warehousing and Logistics Library provides numerous objects that slash the time required to build a warehouse model. Visualization includes informative 2D icons and realistic 3D icons. The Value Stream Mapping Library lets you build, visualize, and analyze your process in value stream mapping format. Although PlantSim's energy attributes, charts, and analysis tools are not a separate add-on library, it's a very nice feature that was recently added to PlantSim's base set of tools, which lets you address an area of growing concern, energy consumption. Although other libraries are also available that provide specialized tools.